logarithms, but I will give about 5 minutes to do a quick recap of what a logarithm is and how we're going to use it, okay? So, let's talk about this first to help things make sense.
So this is the second day in a row we're sitting together. Power team, power team.
Power team.
Don't worry, I got it.
Hey, where's Dixie, by the way?
Another crash?
Ah, the star.
Whoa.
You didn't say that star.
Oh my god. That was not meant with bad intention.
Yes, it was.
She'll be here.
Star, go stand in front of the class and
What?
apologize.
What in your? What was that?
class and say
What was that?
Should I sing
Should we hear it in the class?
in the front class?
Alright, so really quickly, for those of us who are like, man, Mr. Kinney, what the heck do you mean by logarithm? Okay? So, log base 2 of 2 is equal to 1. Log base 2 of 2, or base 2 of 4 is 2. Log base 2 of 8 is 3. Log base 2 of 32.
5.
That's going to be 5.
Oh, that makes sense.
Okay, so what are these over here? What
Whatever it is.
These are the exponents, right? When you evaluate a logarithm, what you're asking is, hey, what exponent goes on this base to give me this argument? That's it. So what exponent goes on 2 to get 8?
3.
So the logarithm is 3. Okay? What exponent goes on 2 to give me 32?
5.
That's the exponent, okay? Log base 5 of 25 then? 2, right? 5 to the second power. So at the end of the day, when we talk about a logarithm, logarithms are exponents. That's it. So it is asking what is the exponent, right? When we do roots, I will point out, like a cube root of 8 is equal to 2, because isn't that the base? 2 to the third is 8. Okay? So a root is finding a base. A logarithm is finding an exponent.
Roots and logarithms, right?
That's what a logarithm is. A logarithm is just finding the exponent. Okay?
Can we use like a root and the logarithm? So we can put, 2 to the 1/3 in the top, and we can use that within the base.
You can do roots and logarithms, but let's just focus on what a logarithm is. So also, because a logarithm is an exponent, logarithms are exponents and the inverse of exponentials. Okay? So if you're trying to undo an exponential, you're going to use a logarithm. Okay? So for example, if I have 10 to the x is equal to 43, and I want to solve for that x, right?
Yes.
So what am I going to do to both sides of this equation?
Log.
I'm going to take a logarithm. Specifically, base 10. Now, base 10 is a special logarithm. It is called the common logarithm. You don't have to write that base. Just write log. It's understood to be base 10. When I do this, again, what I'm asking is, what's the exponent, right? Well, if these bases are the same, what's the exponent?
0? I mean 1.
X.
The exponent would just be x in this case, wouldn't it?
See.
Okay? So what this logarithm has done is canceled out the base of that exponential, left me with x, and then I just type in what's on the right-hand side into my calculator to find out what that exponent is. So a logarithm is the inverse of an exponential. It allows me to solve exponentials. Okay? Yes?
So if it's to get an inverse, if it's a root graph.
Hold off on that for a second. Okay? Okay, so that's a quick background to what a logarithm is. They are exponents. Like when we evaluate a logarithm, we're getting an exponent. That's why, and I know it gets really funky, but if I were to ask you, hey, what's log base 2, and I meant to do this one earlier, log base 2 of 20, I know that it is going to be about, my estimate, 4.2. So with a calculator, please type in log base 2 of 20. By the way, you're going to have to put that base 2 in. The log is above 10 to the x.
Is it because it's close to...
What is it actually?
4.3.
Okay, 4.32. So I didn't get it exact, and I knew I wouldn't, but is that pretty close?
Yes.
Well, log base 2 of 16 is what?
4.
And log base 2 of 32 is
5.
So I knew my exponent had to be between 4 and 5, and it had to be closer to the 4.
Right.
That's all I did. So when you evaluate a logarithm, you're just asking, hey, what is the exponent? That's it. So like here, log base, common log of 43, 10 to the first is 10, 10 to the second is 100, so it's got to be maybe a 1.4, 1.5, somewhere in there. Can someone take the common log of 43? 1.6, okay, so I was a little off, right? That makes sense because of the way the logarithmic function works. Yeah, so 1.6. Notice it's somewhere though between 1 and 2. A logarithm at the end of the day is just an exponent. Now, the other important side of this is the inverse of an exponential. So let's say I have a logarithm. Log base x plus 2 equals 17. If I have a logarithm, what's the inverse of the logarithm going to be?
Exponent.
Be careful with the way you say it, because it's not going to be an exponent like this. It's what? 10 to the x. So where the 10 is my base, making this the exponent. Okay? So what I've done is, and it's like I didn't write it, if I rewrite it as the second step, 10 to the common log of x plus 2 is equal to 10 raised to the 17th.
Right.
So so I had an exponential, so I took a logarithm. Here I have a logarithm, so I do 10 to that logarithm. I make the logarithm the exponent. And because these are inverses, these will cancel. Please don't type that in, because 10 to the 17 would be stupid. But then I can solve that equation. So exponentials and logarithms are inverses of each other. Okay, just a quick little recap, hopefully, of exponentials and logarithms, the algebraic side of things. Okay, so we'll come back to that in a second. Let me build on this before I answer your question, Raina.
Yes.
Because your question goes into the outlier stuff, right?
Yeah.
Okay, so I'm going to do this. We're going to transform two variable quantitative data, and then I'm going to come back to this outlier stuff because there's a thing I wanted to emphasize. All right, so right here, this is where we ended yesterday. Did we talk, okay, did we take the common log of 2.64 and 13.39?
Yes.
What was it? 1.6? Yeah, oh yeah, that actually does make sense because 2.64 is less than 2.75, so it should be below that 0.4386. All right, common log of 13.39? 1.12. Okay, I'll stop there. Please notice, right, this number again should make sense because if I do the common log, what base is that understood to be?
10.
10, right? So 10 to the first is 10. So it needs to be an exponent just a little bit higher than 1. Right? So that's what's happening there. So it's not just random numbers. Nice thing is on the AP Stats exam, do you have to know exactly what a logarithm is?
You do not.
Nope. You just have to, and I will say this even, you don't have to do a ton with it. You just have to
He
be
sounded
able,
like Jonathan.
say again?
I was saying to you that he sounded like Jonathan and played like Jonathan.
So you do not have to know a ton, you just have to, and it may ask 1 or 2 questions total. It's usually not on the free response. It might be one multiple choice question. So I'm not covering it a ton, okay? All right, so what we have this time is, we have our regression line. Oh, by the way, I need to put that point in, right? So 8.4216, somewhere around here.
So we had to put them in.
And then 14, 1.126, somewhere around here. Does that data look more linear now?
Yes.
Yeah,
curved,
though.
I mean, kind of. You can make the argument that it's curved like that, but I mean, that looks way more linear. I got rid of it. It's way more linear than the data set on the other side of the paper. Like the other side, it was literally like a curve around it like this. Okay, so much more linear now. But it says write the equation for the regression line. And so we have this y hat equals But this is again where putting context in actually really matters. What is this x actually in this problem?
A year after 2000.
Okay, so years after 2000. And not the year, because we don't want to put 2014 in. And what is this y?
The predicted stock value.
Predicted, yeah.
It's not predicted stock price, it's predicted what?
It's a log.
Log.
It's the predicted log of the stock price. Because remember, to get this regression line, we took the common log of every single stock price. And so that graph is the log of the stock price. So include context for those variables. Okay, so use the linear model now to predict the stock market price or stock price for 2014. So, log of stock price. Okay, is equal to
Minus 0.1533 plus 0.0871 times 14, which is equal to 1.0.
okay, so common log of stock price, stock at stock equals, what was it equal to?
1.0661.
1.0661. Okay. So is that what everyone else got who attempted it or?
Yes.
Okay. So what do?
We have to do log tonight.
We raise it to the 10.
So we do 10 raised to the logarithm. So you will probably see me do this instead of writing a second step star. You'll just see me write the base 10 raised to that. So like I just write that as one step, and then 10 raised to that. So now the logarithm has been canceled out with its inverse, and so what is the predicted stock price?
11.6.
Okay? Which in year 14,
So
there's that predicted. I don't have that in there, but that's the predicted stock price. $11.6 per share probably is how they are reporting it in the real world context. But notice we just substitute into that equation and then solve for the stock price. We use inverses to undo that linearizing operation. Yes?
You know, in the AP exam, if they recommend us and you recommended us to put the actual name in the predicted
Yeah.
index. So if they're too long, but
Shorten it.
we need to.
So like instead of stock price, just writing stock or just price or something like that. But have enough context in there
Yeah, like long.
that it makes sense for what's happening.
Got it.
Right, like you need the log, but you also need the context, like that variable in there. Okay, does that background on logarithms help this make sense? Or like you look like a question? What you got?
How interpreted?
That's what they told me. They just, I assume everyone just typed this into the calculator
Now interpreted.
and
Yeah.
simplified that. Except Star did it all in his head.
Can you interpret
Interpret what?
R squared? Wait, this is it's the same thing?
The only difference is of the variability
Log.
in the logarithm or common log of stock price is explained, not predicted here, because this is the variability in the actual stock price or the logarithm of the stock price is explained by the linear relationship with years after 2000. So that's how we would interpret it. 95.3% of the variability in the log of the stock price is explained by that linear relationship.
I
Okay?
have 72 right now.
This is just what you say variation,
Hmm?
variation.
Yeah. I'm just used to saying variability, but variation is the same thing. But Lorelai, will you go from there on now? Okay, yes.
Maybe it's not like relevant to the question, but like I think it's like an algebra question. Like, why is it that we don't do like the log stock and then the 1.0661 times to the 10th power?
It's not to, so remember, if it was 10th power, then I would be doing a 10th root. So if I had this 10th root of the stock price
Then you
equals 1.0661, then I would do a 10th power. But remember, the inverse of a logarithm is an exponential, so that's making this the exponent. The 10's not the exponent, the 10 is the base,
Okay.
and that becomes the exponent. Does that make sense?
Yes, sir.
So the exponent is when you have a root. Okay. Okay, so also looking at the residual plot, what does this residual plot tell us about the linear model?
The linear model is more accurate because there's no pattern.
I won't, be careful with more accurate, more appropriate. The linear model is more appropriate because there is less of a pattern or there is no pattern.
Wait, what linear model?
Shouldn't it say it have a pattern because you can make a line out of it?
I mean, I can't make a line out of this, right? And like, I mean, technically, if you try hard enough, you can always make something, but that's not really a pattern. Like, that just wouldn't be. That is a scattered set. Okay, let me also clarify this. Part of the reason why you think there might be a pattern is because years after 2000, I can't have more than one stock price here. So it looks like there might be a bit of a pattern because there's only one point at each of these 2 years. What we're used to seeing is when there's maybe 2 data points at each input, but it's not possible when we're talking about stock prices for the year. But it is scattered. Okay, the pattern has been reduced.
Hey, Mr. Kinney.
Yeah.
Like, what linear model are you talking about? The one that at the top?
The one that we did in number 6,
Okay.
that we just worked with for the rest of that page. Notice that's the residual plot. So if you look at the other side, Ian, look at the other side. That was not a appropriate linear model because there's that pattern around the residual plot. On this one, there's no pattern on the residual plot, so this linear model is more appropriate. Okay? Does that make sense?
It's just
You
kind
mean
of.
like this doesn't have a pattern?
Yeah.
Well, anything has a pattern if you look hard enough.
Well, okay. So hold on to yours, Ryan. Let me re-emphasize this so we all get this. So Ian, what I was pointing out is we are used to scatter plots when each input can have multiple outputs. So it would look something like this, and it wouldn't be any kind of pattern at all. However, when we're talking about the stock prices after 2000, this year can only have one stock price. So I can't have multiple points in that one area. That's why you think that there is kind of a pattern, but it's not really. It's pretty spread out over this. Where I am will not predict whether the residual is above or below the line, or is positive or negative. That's another way to think about it. If knowing what the input is does not immediately tell me if the residual will be positive or negative, then I'm pretty good. Rand.
So since we don't have like a really exact volume to determine if there's a pattern or not, it's just about
Use, yeah.
That's what makes me confused about.
On the actual AP exam, it will be clear. Let me give you an example.
Yeah.
Wasn't planning on doing this yet, but nope, that's not it. Well, might as well pass this out. Emerson, can you make sure everyone gets 2 sheets of that? So these are some free response questions that I picked out for y'all.
Why not star?
Because you're not special enough.
Okay.
Star, can you pass out one of each? So it's 2 papers for each person, okay? So Emerson's giving you a set of free response questions. It's 2 papers per person. Star's doing the same. The difference is what Star is passing out is bivariate, but what type of variables? Quantitative. No, Star.
I am special.
Star is quantitative.
Well, I didn't even look.
Okay. Star is quantitative variables. These are scatter plots here, okay? What Emerson is passing out is for what type of variables? Categorical, okay? So that's because, if you remember, we did not have the bivariate categorical on our last test. We will have bivariate categorical on this test. Okay, with the scatter plot, the bivariate quantitative, I want you to look at 2012 number 1. 2012 number 1. I hate that I'm going ahead and doing this because I wanted us to do this one in class. Scatter plot, bivariate 2012 number 1. I want you to look at that form. 2012 is this one, about sewing machines. This is quantitative, not categorical. There you go. There it is. The form of that graph, the form of that scatter plot, is that linear or non-linear?
Non-linear.
Okay. That data point right here makes it non-linear. If it's ever been a question of linear versus non-linear on the AP exam, it has been that clear. Okay?
Oh, this is a residual one?
No. That's a scatter plot.
I would have found,
Yeah, it's non-linear.
2012.
But like,
You need to use the residual one.
right. You wouldn't need a residual plot. But what I would point out is, let me pull it up this way. What did I say is 2012? So, right here, what I would point out is this. If I were to graph my least squares regression line in here, I would estimate that my least squares regression line may be something like this. Okay? You see that?
Yes, sir.
Okay. Now, remember, all a residual plot is essentially take this line and tilt it, and that's your 0, and then your vertical above or below is the residuals, right? If I think about these points around that least squares regression line, around the 0 on the residual plot, it would look something like this. That's a pattern, right? For sure. That's what I'm saying. Like, you're trying to split hairs, but when it's on the AP exam, they're not going to make it that tight, confusing detail. It is going to either clearly be a curved pattern to include that point, or it's going to be linear. Okay? All right. And we'll work on the rest of that problem later. Ignore it for now. Okay? Yes,
Just a
Brandon.
small request, is it okay for you to reopen the progress checks during the weekends?
Yeah.
So to prepare for that.
Okay. So, quick question, number 11. Which model was more appropriate, using x equals years after 2000 and y equals stock price, or years after 2000 and the log of the stock price?
The law.
Okay?
Log.
The log of the stock price. How did we know? Because I will point out,
The
the which plot?
residual.
Residual plot. I do want you to notice where both of the r's, or r squared is pretty good.
Yes.
Okay? Both of the correlation coefficients were pretty good, but that residual plot told us a lot. So can we just look at our correlation coefficient?
No, you really can't.
You gotta look at correlation coefficient and residual plots. You gotta look at both of them. Okay? Check them both. Because also, the other thing to remember is, if it's not linear, can you even really use R?
No, you really can't.
And so that's where you have to be careful, is if it's not linear, you can't even really use R.
How can being linear connect to making better predictions?
It's not predictions, it's a relationship.
What are you talking about?
In the number 11, I was trying to look at, because page 2, using logarithm because.
I wish I hadn't deleted that slide now. Well, the reality is if it's non-linear, if it's got a pattern around it, so, no, that's not good. Let me pull up yesterday's slides. Oh, today is the 18th, right? So I've already saved this. 7:15. Alright, so right here, to answer your question, this is not going to make very good predictions. Even though I've got a least squares regression line in here, like, these points are pretty far away, or at least there's a pattern that's not going to make a good prediction. Will it make a prediction? Does it give me estimates? Sure, but it's not consistently accurate because of this curve around it, right? And if we were to continue it more, if it's going to continue this exponential curve, this is going to shoot up, whereas this is gonna stay linear.
Got it.
That's the other big thing, to like make predictions into the future, to extrapolate, that's gonna deviate heavily, whereas if I linearized it, it would stick with that
It's
linear
about
prediction.
It's not about like having a just pattern.
Yeah, also, when they say extrapolate, or when they say prediction, they do mean extrapolate. So like, if it's exponential, they're gonna deviate very heavily if you're using a line versus the data being exponential. Okay, so that's one of the things we're talking about there. Okay. Alright, so I'm gonna do these notes, then I'm gonna go back to 3.5 outliers and answer that homework question. Okay, so I don't particularly love the way that Mathematic words it, but if your original data is linear, what do you have to do to make it linear? Nothing. So do nothing. Just graph x versus y. If it's already a linear set of data, you're just going to graph x versus y. Okay. When it's exponential,
Long.
you're going to take a logarithm. And I will say this, and this is why this is not heavily tested on the AP exam. Sometimes it's better to take the logarithm of the inputs. Sometimes it's better to take the logarithms of the outputs. Sometimes it's better to do a million different things. So because there's such a broad span of what you could do, AP exam kind of focuses on one thing, and it's only really ever one part of a there's one multiple choice question. But typically, we're going to take a logarithm of the y, and so we graph x versus the common log of y. Now, if you want, and you're comfortable with it, you can use natural logarithm. Heck, you could use any logarithm, but common log is going to work. It doesn't matter which logarithm you choose, I would use a common log. I don't think I've ever seen natural log be on the AP exam. Because natural log typically doesn't show up until pre-cal, and you don't need pre-cal to take AP stats. So put natural log on there. Okay. Power. Now, this is where I disagree with Mathematic. When they say power, what we really usually mean is like an exponential. Not an exponential, sorry, a polynomial. And so what they have, and you can do, is you can do a log of x and y and graph log x versus log y. I wouldn't. I would just take a root. The reason why you can do a log, they would suggest doing a logarithm, is because the logarithm will always work, like just doing common log always works. But if you think it's quadratic, if you think it's x squared, take a square root. If you think it's x cubed, take a cube root. Okay? So I do an appropriate root. That's usually what I do.
What's an appropriate?
Well, again, if it's cubic, you're not going to take a fourth root, right? If it's cubic, you're going to take a cube root. If you think it's quadratic, you're going to take a square root. Okay?
Well, George is better.
But at the end of the day, you just graph whatever your input and outputs are. Okay? That's it. As a result of the transformation. And the most common on the AP exam is definitely exponential.
Like I said, for your method, would that be square root of x versus square root of y?
So if you do a square root of your, so if you do a root, what I would do is x versus maybe the square root of y. If you took a square root, maybe x versus a cube root of y, if that's what you did, right? So it depends on which root you took, which is why they say a logarithm, because it'll just, you can always do the logarithm and just move on. It's simpler to use a root, so you only have to do one operation, right? Multiple. So when it comes to predictions, substitute the explanatory value in, solve for the predicted value. So, wait a second, and I'll show these examples that I'm referring to. So substitute your x in, your explanatory value in, solve for the predicted value. And when we just had y hat equals a plus bx, you could just substitute in and simplify. Right? So if we just had, so to go back to the dy, or not dyu, the dyu, the predicted weight, right, was equal to, I don't remember, a plus b times the chest girth, right? To determine the predicted weight, you just substitute in chest girth and then simplify. But here, if you had a log of the predicted weight, after you substituted chest girth in and simplified, what would you have to do to figure out what the actual weight is?
To raise it
Put in the
to
get
10.
girth.
Raise it to 10.
You'd have to do, not raise to the 10 raised to
by the
that.
log weight.
So remember, raising to the 10th means you make 10 the exponent.
A base.
But as a base 10 raised to this. So that's what I mean by solve for the predicted value. So if you have a logarithm, you're going to have to do 10 raised to that and 10 raised to this to get what the predicted value is. So you have to substitute in and then solve for the predicted value. If it was the square root of y hat, once you substitute your x value in, what are you going to have to do to find the predicted value?
Square root.
Not square root,
I mean,
square.
square.
Make sure whatever you do to one side of the equation, you do to the entire other side. I will say I would simplify first and then square. I would not square the a plus bx. I would substitute x in, simplify, then square. Okay? Alright. I'm gonna pause for a second, let that digest, see what questions you have, and then answer those 3.5 more questions. Yes? Alright. What number was that? Number 3?
Oh, yeah, number 3. So, I think we briefly looked over the next one. I just wasn't sure if I can say increases the correlation, but it's still an outlier.
So what effect does the point have on the correlation between x and y? By having this point way out here, what does it do to the correlation?
It makes it more linear, but
So it increases the correlation. Now, why does it increase the correlation?
because
It's directly
it
on
is
the line.
similar within the
It
regression
is
line.
within the regression line, or the pattern, that's what I should say, within the pattern,
Of the regression line.
not of the regression line,
Of the rest.
of the rest of the points. So because that point's way out there, it's gonna continue that pattern, it's gonna make it a stronger pattern.
Do I need,
Now,
still need to state that as an outlier?
So I was looking at the notes in the textbook, and we would call that a,
Potential outlier. I said a
no, so that's why I don't love it. We wouldn't call this an outlier because outliers specifically, so please update this if I was unclear about this before. Outliers specifically have to have large residuals. That does not have a large residual, huh? It says it that way in the book? Yeah. I can't remember if I was clearly communicating that or not, so I was going to go back and recap something. But that would not be called an outlier. It would be a high leverage point because it's
Yes.
horizontally far from the data,
You said that.
but it is not an outlier, because it does not have a large
On
percentage.
the last unit, you said
What do you mean by a lot of difference?
So like, if I were to have this point right here,
Oh,
so if I were to add this point, okay, right here,
yeah.
that is high leverage because it's horizontally far from the rest of the data. It would also be an outlier because it has a large residual.
So it means that there's a lot of difference between predictive odds and actual.
Correct, yeah. So outliers specifically are all about the residual. So if it's a large residual, then we can call it an outlier. Now this would be a horizontal and vertical outlier, whereas this, well actually that would just be a horizontal outlier. This would just be a vertical outlier, yeah. So, yeah, if it has a large residual, large enough residual, we don't quantify that, but a large enough residual, it's an outlier. That would not be an outlier. It would still be high leverage, right? But it's not gonna be an outlier because it is right on the regression line. It's gonna strengthen the correlation, but that's it. Okay? Notice this point might translate it down a little bit, so maybe an influential observation. This would almost guarantee tilt the line, so it's probably an influential observation, things like that.
I think I remember, looking back at now, since you mentioned influential, in the 3.5 number 1 homework, I said it's all influential, but I wasn't sure of that.
I would say A and B are influential because
Yeah.
A would probably translate that line up, and it definitely affects the correlation and lowers the correlation. So it's an influential observation if it affects slope, y-intercept, and/or correlation. That definitely affects correlation, A does, and it would probably translate it up a little bit. B, being way out there, would rotate that line, and so it would affect correlation and slope and y-intercept. Yep. And B would be high leverage, A would not be a high leverage, B would be an outlier, A would be an outlier. Okay. So, sorry, so just to make sure this is more clear, and Madeline, you're 100% right. The textbook very clearly says outliers have large residuals, okay? So if it is horizontally far away, but it doesn't have a large residual, it's not gonna be called an outlier. Outliers have large residuals.
What are we considering large?
Yep,
Okay.
That's
if it deviates from the pattern, right? So if it clearly deviates from the pattern, it has a large residual, then it's gonna be an outlier. But remember, I told you on the AP exam, you're never gonna be asked to quantify an outlier for the bivariate data,
Perfect.
just for univariate, okay? High leverage means it's horizontally far from the data, and influential observations change the slope, the y-intercept, or the correlation, okay? The presence or the removal.
In the latest, just curiosity, is there actually a way to identify outliers in bivariate data, or are we just not getting?
I am sure that there is a way.
But it's too complicated.
I don't know that it's too complicated, but we just have bigger priorities, is how I would word it. Okay. Alright. Okay. So we did the outliers recap, finished transforming two variable quantitative data. We're gonna do one more quick thing. That's gonna be more direct instruction-esque, and then, which we'll do right before lunch, and then AP pre-response questions we get back. Please do not forget test corrections. I don't think, did I ever give you all an actual date for the test corrections?
today.
Today?
Yeah.
Oh, Thursday or Friday, I'll let y'all do it tomorrow, because I did not,
You said that.
do that. Did I?
What the, who's that Friday?
Y'all wanted to take them up today?
I mean, I'll take them up today. I'll take them up today. I think I did say Thursday so I could give you feedback before Friday, but I forgot to remind y'all that's on me. Regardless, every teacher has to do an ACT practice test for juniors and below. Seniors, you don't have to worry about this. Because we're in an AP class, I don't have time to take 20 to 30 minutes for y'all to do a shortened math portion. So juniors, I'm going to assign it in Schoology. Just have to have it done before Monday or Tuesday. I'll give you until Tuesday.
Oh, wait, what?
Juniors only.
Okay, never mind.
Don't worry about it.
It's close here.
So I will post it in Schoology, I'll assign it. It's literally a shortened math portion of the ACT, and we're just gonna have to use that to, it's just, whatever. Juniors, y'all have to take the,
Pre-ACT and ACT.
no, ACT. You have to do a practice ACT though for the school on Tuesday, if no one's told y'all yet.
So is it then Tuesday and tomorrow at the same time, so those.
So you have to do a short math one for me, and that's it. And then y'all have an actual practice ACT first and second block on Tuesday.
So how's doing this one?
I have a question.
We're supposed to have already done it.
First and second.
Maybe it's a little bit different. All right, guys. I need y'all to look at the last lesson. We'll do that check understanding later. So the last lesson in this unit, lesson 3.7. I don't fully actually remember what the title of it is, and apparently I didn't put it in here. That one. How close can you get to the
Finish
finish
line.
line? Okay. I don't have the materials to do this one, and also I don't want to spend a ton of time on this. So what I did is I just stole, sorry mathematics, I stole the data that they provided for when they did this with their own class. Nope, that's not what I
That's
want.
class?
Huh? Mathematics?
Oh, J-Ho. I just said J-Ho. Like, what? I said BT. I don't know what it is.
Here we go.
Tell them life story.
Okay,
Tell them.
so right here,
Get a life.
so what it is it's taking cars, pulling them back, the wind-up cars, 2, 4, 6, 8 inches, and then letting them go. And so here's some data they got. So they graphed the linear x and y, and this is the residual. So first off, pretty good R squared, right? Here's the residual plot they got though. So is graphing it as just x comma y appropriate?
No.
No. By the way, I'll just email this to y'all. Don't sweat writing all this down. I just want to talk through these things. So right here, what they did is they took every single x value, and what did they do to the x values this time actually?
Swear it.
They squared it. Why do you think they did that looking here?
Because it,
To get them higher.
It would to linearize, because what shape does this look like?
Qubit.
almost parabolic.
So it could be exponential, or it could be a parabola, half of a parabola, okay? Personally, instead of squaring the x, I would have square rooted the y. That's how I would have done it if I was doing this. Notice, stronger or worse in terms of r and r squared?
It's stronger.
Stronger.
Very stronger.
Do we still have a little bit of a pattern though? Yeah, so let's see what else they did. So notice they did x squared and y. This one they did
Log it.
the logarithm, right? Thinking it was exponential. Notice almost exactly the same r and r squared, but look at that scatter plot, or the residual plot. Better or worse?
Better.
Better.
They also, it's still bumped up.
Okay, still a little bit better, right? And so what we need to recognize is when we talk about which model is the best, can we look at just one measure?
No.
No. We have to look at the correlation coefficient, we have to look at the coefficient of determination, and we need to look at a residual plot. If I just looked at r and r squared, I could have stopped with that linear, but the linear model would not have been the best predictor. Okay? And so they said, model 3, highest r squared, residual plot shows no patterns, and they do practice applying that idea. But I just wanted to talk through those big ideas before lunch. So how to check the best regression model. I'm just going to let y'all go ahead and grab this. So first things first, you got to check the scatter plot, right? Like that scatter plot needs to have a linear pattern. If it doesn't, use something else. Sometimes you can't easily see it. That's why you then check the residual plot for no leftover pattern. And then you want the best r squared, or the best r. You can copy that down when you get back, head on to lunch, but that's where we'll pick up from there. Yes, sir. Thank you.
Can I ask you about a question from my test?
Yes. Because you were the one asking me one that marked wrong that you got right? Okay. Let's start on that check your understanding.
Hey, team.
There you go. No, just where you are, we'll do some later.
I love
C is that one on the right.
C is the one on the rightmost section over here, yeah. So remember, if you look here, it says the natural log of the predicted life expectancy equals 4.1393 plus 0.0603 times the natural log of the income. So I took the natural log of 80, but I just typed this whole thing into the calculator.
Okay.
And then when I got to the natural log of predicted life expectancy equals that, same as before, I just did e raised to that power and e raised to that power. So if you can do B, you can do C. You just have to be aware. So like what they're saying is, remember that's that idea of a power function that they're addressing there. Which again, I probably would have maybe just done some kind of root to make it simpler, but they said it's a power function. So they took a logarithm of both the explanatory and response variable. Yes, Steve?
I did that one calculator, but I got 3.31 times 10 to the 33rd power.
What?
I'm going to go out on a limb and say you put something in wrong.
I did the natural number. Natural.
No, that you did e to the 80th.
That's a lot.
No, I did not tell you to do that.
You need the natural log. You didn't hit the control. Yeah. You need the natural log.
Oh,
of
I
80.
should have come here, so
Okay.
right.
All right. Now, really quickly, just looking at this, looking at the information given, which of these models would probably be the best to use predicting life expectancy?
C.
I would go with C as well. Notice it is the most scattered. There's a slight pattern left over in each of these, right? But there's really no pattern at all discernible in model C. So looking at residual plots, the transformed residual plots, yes?
Oh, you're not supposed to put the hat over the whole thing. Why isn't that on that side?
Don't sweat that detail. I need to look at that. I think technically it is supposed to be a hat over the whole thing. But we're really only predicting the life expectancy. So the natural log of the predicted life expectancy, I need to look. Because I was struggling with that earlier today as well. It's not a detail that will be factored in. One thing that I do want to point out is make sure you take the time to show your values substituted into that equation. Okay, take the time to show your values substituted into the equation before continuing, because a reader can read with your mistakes if you show certain steps. So show that work. Yes, Ian?
Can you like go over like how do we get from the top graph to the bottom graph on each one for a model?
Well, remember these are scatter plots, or yeah, these are scatter plots, these are residual plots. So these are the residuals. So like if you were to find the distance between the actual and the predicted, that's what's being graphed down here,
Okay.
right? So to get these scatter plots, it was applying those transformations and then they just gave you the residual plot.
Thank you.
Okay?
Is
Yep.
it enough to just put the numbers, or do I need to include, natural log life hat?
I mean, if you use a model C, you need to write out the equation with the natural logs on there.
Yeah.
Okay. All right. Here's what I want us to do at this point, is I want us to start working a little bit on some AP free response. I think probably the best one to maybe do right now let's do the 2018 number 1. Okay, so this is 2018 number 1. This is one of the ones that somebody passed out earlier.
It was me. It was
Star had the passed out. Okay, 2018 number 1. It's only 3 parts. It's a little bit quicker of a one. We want to cover a few things, so I'm going to give y'all 10 minutes, which is definitely less than the normal amount of time. Oh, you don't need that. You're good. So I'm going to give you 10 minutes to work individually to start, and then I'll have y'all talk for 5 minutes before we start going. Okay?
2012.
2018.
This graph is weird.
You got it. You got that. Yep. There it is.
Oh.
And go.
Is this graph supposed to be like that?
Why wouldn't it? Oh, I see what you're saying. I wouldn't sweat it. Yeah. Yeah, don't stress it. I see your problem with it. Don't stress it. So, Star, what did you say, or how did you interpret this? And y'all listen and see if we can find what is slightly missing.
If there were 0 customers in line, it would take 72.95 seconds to check out.
What is wrong with what he said?
He said yes.
Predicted volume.
It is predicted to
It's not the
take.
actual volume.
Yeah, do we know that it's going to
Yeah.
take you exactly 72.95
I
seconds?
realized it.
So a lot of y'all did a great job of that, right? We got to remember though, that everything on this least squares regression line is a prediction. So if there are 0 customers in line, it is predicted to take 72.95 seconds
So I get-
to check out.
So what I get a P for that?
I would imagine so, yes. I have to look at the actual rubric, which we'll do in a second. Yes.
You can also say estimate too, correct?
Be careful.
It is estimated to take, or it is, yeah, it's estimated or predicted. Just be careful with the word estimate, because Phoebe wrote about estimate as well, but she said that the y-intercept is estimated, but the y-intercept's not estimated. The y-intercept
wait
is
time.
72.95, the wait time is estimated to be 72.95. So that's why it's cleaner to just say predicted.
So in the notes that you wrote, it says it is necessary to put the predicted y context, but it just says x is 0. I went ahead and put the context of x,
I would always put the context.
yeah.
If there's values and you got a context for it, put that context in there.
So the number of customers in line is 0.
Right. Yep. Okay, coefficient determination, I think we did pretty well on that, so I'm gonna skip over that, we'll look at the answer in a second. One of the data points was determined to be an outlier. Which one was that?
3.
The
one
3
on 3.
something?
3.
And why is that an outlier? So why? Let's answer that question first. Star?
Because it's not a part of the cluster and the residual is very large.
Okay, so it have a very large residual, it's not a part of the rest of the data set. But I do want to point this out, because it's very tempting to start talking about things that are not asked about. Because I saw someone was talking about it or thinking about it. Does it ask us how it affects the least squares regression line?
No.
So are they asking for any comments about slope, or about y-intercepts, or about correlation here? No. So, those things would be extraneous. They might be useful. We'll see what the rubric says in a second, but it only asks what would make it an outlier. Well, it has a large residual. That's what makes it an outlier. Yes, Madeline?
Says it's determined, we don't have to call it potential.
Correct. So it is determined to be an outlier. It is an outlier. Correct. Good question.
Wait,
Do I need, is it okay to just say, because it has a higher residual value, I go ahead and add it, which means that there are great or large difference between actual value and predicted value? Do
I mean,
necessarily?
saying it has a large residual already says that. You can say that extra bit.
Yeah,
Just be careful about adding things that aren't necessary,
yeah.
because you might misstate something. It has a large residual though.
Is this part okay? It is far outside of the rest of the data.
Yes, but make sure you talk about residual. We'll see what they say here in the rubric in a second. Okay, so here's the ideal answers, right? Notice the estimate of the intercept is 72.95. It is estimated that the average time to finish checkout, if there are no other customers, is at 72.95. So they use the estimate here, not predicted. I would use predicted. It's more modern to say predicted, but I think this was 2018, so 7 years ago is a bit. Okay, coefficient determination. We seem to be getting better at this, right? It's that percent of variability in the time it takes customers to finish checkout that's being explained, and I don't like they don't include this, but it can be explained with the linear relationship of how many customers are in line in front of the selected customer. The reason I say that is because in the rubrics in the last 4 to 5 years, you've had to include that detail about a linear relationship. Because if it was non-linear, it would be explained by the non-linear relationship. Yes, Madeline?
do we have to put that first sentence on there? Like, I just wrote, like.
In part B or C?
B, because.
I mean, it just asks, if you interpret it, then you've already identified what it is. Well, let's also look at what the rubric says, right? So here's what A says. Okay, so E, if you got the right y-intercept, you talk about the context of time and 0 customers, and you have to indicate that the value is a prediction by using language such as predicted, estimated, or average value of y. So yeah, sorry, that'd be a P because you only had 2 of those 3. Yeah, but that's what we want to pay attention to, context and being attentive to those details. Okay, B here, you have to correctly identify 73.33% as the coefficient of determination. If you are interpreting that R squared, so I will say that you might want to make sure that you have a clear note of this is what R squared is, but I think if you interpreted it correctly, you'd be fine. But you had to have those 3 things. Let's see. Yes.
I'm only missing the part where you said linear relationship, but it just.
So notice in this rubric, it doesn't ask for a linear relationship. on a more modern rubric, it will probably, at least in my recent experience, it is asked for that understanding of this with a linear relationship. So it depends on the rubric. So I don't want to say you would definitely get a P or not. It depends on who makes the rubric that year. But if you include that detail of a linear relationship with the number of customers in line, you're guaranteed to get the full credit.
I'd be graded
Okay.
at AP stats, yeah,
Which, like,
like the actual one.
yeah,
Bro,
2 or 3
Oh,
times.
you
Yeah.
go to national?
I didn't get to go last year because I was in Copenhagen, but I've done it for a few
isn't
times.
that like Germany?
It's in Denmark.
Denmark.
Denmark. Close
It's the capital of
I
Denmark.
ain't know my job.
Okay.
Oh, I should probably know that.
Okay, so notice this is generic, is what they're saying, these examples of like component 2. But if you just do it in context instead of generically, then you're gonna be good, and they want it in context these days. All right, part C. You have to correctly identify the outlier, describe an unusual feature, so it's unusual compared to the other points, much lower than expected, so a large residual. So you just had to hit one of those 3 things, right? The residual is unusually large relative to the other residuals. Yes. If I have some back there, if not, I need to go grab some, let me know. Yes, Raina.
No, I'll ask you later, because it's not a question about this.
Okay, so hold on to that. All right. We don't have a ton of time at this point to do something else. We have about 7 minutes, so let me look here. I hate that, I am so sorry.
I'll buy some for you.
I appreciate you. All right, so let's just do this. Let's do 2012 number 1,
I was 3 when this.
okay? I had graduated high school 3 years before this.
Jeez.
3 years before 2012?
No, I thought you said.
Hey guys, 2012 number 1, or just part A. So I want you to look at 2012, just part A really quickly, and then we're going to talk about it. So part 2012, part A, really quickly. Last Band-Aid, so I gotta buy some more. I need them to give me money to buy stuff.
Don't you just have like credit cards or like a
Yeah,
card?
but
Can
I
if you
need
send
money
out a
for
list,
my
I'll
family.
buy some. I'll
The association between the price of a sewing machine and their quality rating.
Almost
No.
Almost done.
Be careful. It'd be almost none if it was like this,
Oh, true, my bad.
right? So it's more than just none, but I heard weak. Is it fair to say there's a weak relationship?
There's a fairly weak
Yeah,
relationship.
especially right here, it's pretty weak. Okay, so it is positive. So there is a positive, but weak. You could also say and, it's fine either way. Positive but weak.
We're there.
I say, remember, we looked at this one earlier, and there's that
Non-linear.
curve there. So
Non-linear.
positive but weak, non-linear
Linear.
Relationship,
relationship between
price, and quality of solution.
price and quality of sewing machine, okay? So, I want to pause, I want to talk about something, because this was an interesting detail that was asked on an AP exam one time. They actually asked students to clarify, like, what do you actually mean by positive? What does it mean to say that there's a positive relationship? It's overall increasing. So, as X increases,
The Y
the Y also is increasing. Like, so notice, and we want context, but like, what does it mean to be positive? Oh, as the price increases, overall the quality rating increases. What does it mean for there to be a weak relationship?
It's not very relationship.
It doesn't have a correlation.
So there's not a high strength, there's not a high correlation, their predictive ability is not very strong.
Well, we don't really use R if it's not linear.
So, and then just be careful with saying just between 0 and 0.5, because again, that only works for linear, but we said non-linear. Overall, guys, when we talk about the strength of a relationship, it's how predictive is that? And when I look right here and I see all this spread, is any kind of model going to predict this data well?
Well, no.
Not really, right? So when it's a weak relationship, hey, our models are not going to be very predictive. If it was really strong, if my data looks like this, Now we'll point this out. That would be pretty strong, right?
Yeah.
So why is that strong? Because those data points are really
Close to the.
closely related to a model, right? So like when the data points are close to that model, when they're close to that form, then it's a stronger relationship. Finally, what do we mean by this being linear? And it sounds goofy, but they literally asked that question. What does it mean for this to be linear?
Eric said it correlates.
I mean, it's the same exponent.
Okay, so like just in general, so
Can
you know,
have an R value?
well, but like that's a result of it being linear. What does the fact that it is linear mean? It means that it looks like a
Increase.
well, increase is the positive idea. The fact that it looks like a line is what makes it linear, right? So if the data points look like they follow a line, it's linear. So make sure you think through it. I think the book goes into some details about those kinds of things. Tomorrow's DYU, I will say that it's going to be the second half of the unit. I'm going to include a little bit maybe from segmented bar graphs or mosaic plots, relative frequencies, because that will be on your test. So make sure you study that. Your entire Fourier model should be completed before tomorrow. And we will do the DYU, we'll spend some practice time on some more AP free response questions.
Yes, sir.
Do,
2012 finish it?
no.
Okay, sorry.
Do the second categorical data question. Sorry, I was trying to think through what that is. The second categorical one, not the first, I wanna, ooh, just kidding.
Charlie.
Yeah, do the second one, do number 2, on the categorical free response.
No, Charlie.
Categorical free, no, this one. So there's no years with it. This is a 2 variable categorical, number 2. So
Wait, somebody order farm in front of the camera
number 1
with
in
me.
class tomorrow. Thank you. Bye.
He'll be on the fly. You're so funny. Are we doing part 4 today?
Are we marching part 4?
Yes.
Non-linear, do you have a way to
I don't know part 4.
I was trying to look to see if.
If Miss Eversing is mad at me again today, she can run the whole field like I'm mad at too.
No, it is not.
You wanna know something? Guard doesn't even, I don't think guard knows their choreography. Yeah.
Only one of the.
Yeah.
Like,
Okay.
Bro, Emma better get that right today. I don't want to hear Emma, your head's up. I'm gonna turn around and fight.
You wanna know something? I'm not saying the word anymore because she,
You can stop.
I'm not.